Hello everyone. Welcome back to my YouTube channel. Today we are going to solve the POTD of lead code. First of all, let's go through the problem statement. The problem name is count the number of fair pairs. In this question we are given an integer array nums of size n, and we are given two integers, that is lower and upper, and we have to find the pairs I comma j such that j should be greater than I, and nums of I plus nums of j should lie between lower and upper. Both are inclusive. To solve this question, let's see with an example how we can solve this question. Let's take this example itself. So, to solve this question, forget about the first condition, that is j should be greater than I. Why I am telling you this? I will tell the reason behind it in the last. So now focus on the question. So to solve this question, first of all, sort this array. So after sorting it, the array will look like 0 comma 1 comma 4 comma 4 comma 5 comma 7. Now what we will do is we will traverse this array from 0 to n minus 1, and for every index I we will check from 0 to I minus 1 how many indexes are there which can form pair with index I. So this is the overall logic for this question, and we are going to solve it using this logic. So for index 0, let's say the other value is x. So for x plus 0 should lie between 6 and 3. This implies that x should lie between 3 and 6. But from index 0 to I minus 1, there is no value which will satisfy this condition. Okay. So now we will move on to index 1. So for this one, x plus 1 should lie between 3 and 6. This implies that x should lie between 2 and 5. So before this index, there is no other index whose value lies between 2 and 5. So now we will move on to index 2. So for this index, x plus 4 should lie between 6 and 3. This implies that x should lie between -1 and 2. So how many indexes are from 0 to I minus 1 which is satisfying this condition? So index 0 and index 1 is satisfying this condition. So for this, answer would be 0 comma 2 and 1 comma 2. Now we will move on to index 3. So for this index, x plus 4 should lie between 6 and 3. This implies x should lie between -1 and 2. For this also, we are having uh, in this range we are having only index 0 and 1 which is satisfying this condition. So for this also, answer would be 0 comma 4 and 0 comma 3 and 1 comma 3. These are indexes. Okay, so now for index 4, Now we came to index 4, and for this x plus 5 should lie between 6 and 3. This implies x should lie between minus 2 and 1. So how many indexes are there which are satisfying this condition in this range? So there is index 0 comma 0 and 1 which is satisfying this condition. So for this also answer would be 0 comma 4 and 1 comma 4. Now we came to index 5. Now for index 5, the condition is x plus 7 should lie between 6 and 3. This implies x should lie between minus 4 and minus 1. So how many indexes are in this range which are satisfying this condition? There is no index. Okay. So how many total pairs we found which are satisfying the condition of nums I plus nums j should lie between lower and upper is 6, that is 2 here, 2 here and 2 here. So answer for it would be 6. Okay, so now let me tell you why I have told you to forget about the condition 1, that is j should be greater than I. Let's say x comma y is valid pair. Okay, and index of x is a and index of y is b. If a is greater than b, then it automatically become j and it will become I. And if b is greater than a, then it automatically become j and this will automatically become I. That's the reason I have told you to forget about the uh, condition 1, that is j should be greater than I, because that would be taken care automatically. Okay, and here I have to tell one thing more. Here we are calculating the answer on the go, like we are calculating the answer while traversing this array. So this will help us from the duplicacy, like we are considering I comma j, then it won't allow us to consider the index j comma I. Okay, so uh, this is the overall approach for this question. So now let's see the code for it. So first of all we are sorting this array, and after that we are calculating the lower value, that is lower bound, that would be lower minus nums I, then upper bound, that would be upper minus nums I. Now to find how many previous indexes are satisfying the condition, we have used the binary search. So how it is working, let me explain you. Like if we have to find the indexes from 0 to I minus 1 which are satisfying the particular condition, we are using two binary search. First binary search will give the lowest index and second will give the upper index. So answer would be upper index minus a lower index plus 1. Okay, so to find the lowest index, we are considering this condition, that is x should be greater than equals to 3, or we can say lower bound. And to find the upper index we are considering this condition, that is x should be less than equals to 6, or we can say that x is less than equals to upper bound. So using binary search lower bound index, we are calculating the lower index, and for upper index, we are calculating it with using binary search upper bound index. And if there is no valid index, in that case we are returning -1. So if LBI and UBI is not equals to -1, then only we are adding it into our answer. So this is the code for binary search lower bound index, and this is the code for binary search upper bound index. So if you found this video useful, do like and share with your friends. That's all for today. See you tomorrow. Bye.